Every year in Europe, 130 million cubic meters of polluted river sediments are dredged and need to be disposed of in specific and expensive ways, up to 7,000 euros per ton. Every year, 5.2 million cubic meters of soil are removed from the ground due to plant nursing activities. To prevent the risk of a tendency which would lead to a 8 to 10 mm per year lowering of the ground level, plant nurseries are forced to buy soil from third-party catchments, which are often of poor quality and contribute to soil exploitation elsewhere. Similar problems are faced by the EU road building industry, whose yearly demand for sand, gravel and aggregates for stability and draining purposes is around 30 million cubic meters, for an average value of 450 million euro. The CLEANS project shows how polluted dredged river sediments can be treated and used within two different production processes in an ecologically and financially advantageous way. The sediments are turned from a valueless and expensive waste into a valuable raw material, guaranteeing the full environmental and financial sustainability of the approach. The physical-chemical characteristics of decontaminated sediments make it possible to smoothly include them in current production processes. The CLEANS project demonstrated and evaluated an innovative integrated multi-sector approach for the smart and sustainable management of polluted dredged river sediments to be reused in two different sectors: road construction as a filling material, plant nurseries as a substrate and amender. The project brings together the problems and needs of three different sectors: management of dredged sediments, plant nursing, road building, demonstrating an innovative and fully sustainable set of strategies that allows public and private stakeholders to face their existing challenges in new and more effective ways. After a preliminary characterization of some sediment samples dredged in different locations of the Navicelli Canal, the more idoneous sample was selected and dredged in the quantity of about 800 cubic meters. The dredged material was deposited in a Navicelli basin and, on the basis of chemical physical properties, undergo to a land farming process, selected as the most appropriate technology, enabling to reduce water content, organic matter and organic contaminants. The analysis carried out on the sediment after about 5 months of land farming confirmed the general suitability of the sediment for its reuse in road construction. For plant nursery purpose, sediments decontaminated with plants, phytotreatment and organic amendment in the framework of a previous European-funded project, AgriPort, were used. The results of the characterization suggested the need to subject the sediments to a land farming treatment with the aim to homogenize the substrate, to increase the biological activities and, as a consequence, to further reduce the organic contamination. 2 months land farming process were particularly effective in improving biological activity and further decreasing organic contamination in the sediments. However, due to the lower nutrient content and water holding capacity, a mix of sediments with an organic matrix, such as agronomic soil, has been necessary. The trials in nursery activity were set up preparing 6 cold frames of about 3 per 3 meters each with 3 substrates: T0, agronomic soil 100%, T33, decontaminated river sediment 33% and agronomic soil 66%, T50, decontaminated river sediment 50% and agronomic soil 50%. 3 ornamental species have been selected: Photinia fraseri, Viburnum tinus and Elenius macrophyllum. 48 plants for each species were used, for a total of 144 plants. Aggregating power of the sediments on the soils, assessment of the hydraulic characteristic of the mixture, and growth and quality features of plants were demonstrated. The partners who gave their contribution to this important result are Institute for Ecosystem Studies of the National Research Council of Italy, which was responsible of the project sediment analysis and which acted as a project coordinator. Department of Civil Engineering of Pisa University, expert in road construction, which was responsible of the specific Italian cleansed road building. Centro de Edafología y Biología Aplicada del Segura, of the Spanish National Research Council, which was responsible of the project sediment treatment and analysis. Institute of Biometeorology of the National Research Council of Italy, specialized in plant nursing, which was responsible of the Italian cleans experimentation and field application for plant nursing. Navicelli SPA, an Italian company supplier of project sediment and expert in sediment treatment. Department of Plant, Soil and Environmental Sciences of Florence University, expert in plant nursing and toxicity. At the end of the project, the following objectives are achieved. About 800 cubic meters of sediments were dredged from the Navicelli Canal. The fresh dredged sediments to be reused in road construction and the sediments already treated with AgriPort Fit technology were characterized from chemical, physical and biological point of view. The land farming treatment, used alone or as post-treatment, were defined as the most suitable treatment for both sediments. The sediments were characterized from a chemical, physical and biological point of view during the whole land farming process. The selected land farming methodology was effective in the decontamination, reduction of organic pollutant of about 95% in dredged sediments, and the transformation of sediments in matrices reusable in road and nursery activities. However, due to the lower nutrient content and water holding capacity, a mix of sediments with an organic matrix, such as agronomic soil, was suggested for nursery activity. Instead, in road construction, another chemical treatment was necessary in order to further reduce the water content. The suitability of sediment, different mixtures sediment agronomic soil, in plant nursery activity were tested and monitored through periodical chemical, physical and biological analysis of the agronomic substrate, growth and physiological stress of plants. The sediments mixtures resulted suitable for in-field cultivation of shrub species, since plant growth and physiological response were equal for Elanius macrophylla and Photinia fraseri, or better, Viburnum tinus, than in the agronomic soil traditionally exploited for plant nursing. A percentage of 33% decontaminated sediments in the mixture gave also the best performance for some species in terms of root vitality. A 100-meter-long road was constructed with treated fresh sediments after another chemical treatment consisting in the use of lime in order to further reduce the sediment water content. Since the sediments were classified in the A76 group, they were used in the body of the embankment. The monitoring activity carried out confirmed the suitability of the sediment for road construction. The smart management of contaminated sediments. Instead of being treated at an average price of €75 per cubic meter, the sediments were treated at €35 per cubic meter and turned into clean raw material with a market value between €10 and €20 per cubic meter. This means a 66 to 80% net saving for sediment decontamination. The partners made sure that the project made maximum visibility at a European level. During the project, a lot of dissemination material was produced, which was then distributed at fairs and conferences, and which was published in newsletters and blogs. A logo, several posters, flyers and brochures were designed and guaranteed a large dissemination of the project and of the project results. The partners gave interviews to TV channels, and a project website was published online since the third month of the project.